So you've become an expert at the graphing method. You've become an expert at the substitution method. And there is actually a third method to solve systems, and we call it the elimination method, okay? So we're going to walk through just those general steps right now in a more basic elimination problem. So you should have been writing these steps down in your notes as you worked along with the Nearpod. So if you haven't already, make sure you started by writing step number 1, line up the equations by variable, and then here's that first step. So what this step means is that you want to look to make sure your x's are lined up, which they are. My y's are lined up, which they are. My equal signs are lined up, which they are. And the plain old numbers are lined up, which they are. Now, for the record, they could look like this. This would also qualify, right? My y's are lined up, my equals are lined up, my x's are lined up, my plain numbers are lined up. I don't care how they're lined up, it's just that they actually are lined up is what matters. The order does not matter. So that was step 1. Step 2, and take a pause if you need to and write down step 2, again from the Nearpod, and it says, determine which variable you're going to eliminate. You may have to multiply. So the goal here with the elimination method is to add your variables up and down, as weird as that sounds, and have one of them eliminate. And I'll show you why that works so nicely. So if I were to add down, I have 4x plus 2x, and I get 6x. I have positive 2y minus 2y. Well, doesn't that eliminate out to be 0? So this is where that elimination method comes from. We've eliminated our y's, and over here, we add these, and we get 36. So what's cool about what I just did here is because those y's are gone, I could divide both sides by 6, and I get x equals 6. So I have this problem already half solved, okay? So like it says, step 3, add your equations and solve for the leftover variable. Now you probably already know what to do next. Once you have one variable, you just plug it back into either equation up here to solve for the other variable. It doesn't matter which one you pick. So I don't know, I'll pick the second one. 2x minus 2y equals 5. And I'm going to substitute in a 6 wherever there's an x. 12 minus 2y equals 5. So now you take a second and finish this problem out. See what you get. Did you get y equals 7/2? Just because it was a fraction doesn't mean you have to panic. You just know that we always write our answers out as x comma y with parentheses and a comma because it's a coordinate point where these two lines intersect. So that's how I would write my final answer. And so again, a quick recap. This is a more basic elimination problem because when you looked at the y's, they naturally added to 0, okay? So it made it kind of easy. So all you have to do is make sure variables are lined up, you add down, and then you solve for the first variable, and then you plug in to solve for the other variable, which is not that unlike substitution method at the end as well.